Yo, 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 Math by the Moon, back with another video. Today we're going to look at simplifying cube roots. So let's get started. Remember how we deal with notes. If you need to pause, if I ask you to pause, please do so throughout this. You will be asked to submit a picture of your work. All right, so here we go. Let me get this off of here. Here we go. And this was a list of cubes that we did the very first entry in your notes, so you should be familiar with those numbers. If you can't memorize them, you should at least be able to recreate those numbers by just simply typing some things in your calculator. You might know them about up to 125, and if you remember, I call that the devil's cube and so on. And in the first video, there were some neat ways to remember some of these. But we're going to come back and forth to this because this is how since we know these are called perfect cubes, this is how we will answer the question for what is a cube root. So just like square roots, but square roots took a pair, cube roots take a set of 3 identical factors. So if I wanted to know the cube root of 125, I would go back and think about what that cube was on this previous slide. So cube root of 125, the number that multiplied by itself 3 times would have been a 5. So there's your answer to the cube root of 125. We bounce back and forth there. 512 was 8. Cube root of 8 is 2. And 729 is 9 times 9 times 9. And we can see those all right here. Now remember on this video we did cube all the negatives, right? And I thought this image was kind of funny. It's the cube root, literally cube root, but it's also covering up some of the things I want to look at next, which are those negative roots. So the cube root of negative 125 is negative 5, because negative 5 times negative 5 times negative 5 is negative 125. So you can really do the cube root of a negative number. Remember, we had the list of all of our cubes from 0 to 10, but also from negative 1 to negative 10. So we can actually get these answers. And that's going to play an important role in how we simplify cube roots when the number, the radicand, the number inside the cube root is a negative. I think you're going to like procedurally how similar this is to simplifying square roots. Okay, so the first one here I see is a cube root of 40. And I'm thinking about these cubes and I'm thinking, okay, I wonder if any of these cubes go into 40. So I'm looking at just the ones here, and I know 8 goes into 40. So I'm going to use the cube method real quick without using a factor tree, because I know the cube root of 40 is the same as the cube root of 8 times the cube root of 5, which means this would equal the cube 2 times the cube root of 5. Okay? Now, if you're looking for the cube root, you probably found the square root, but if you're looking for the cube root in your calculator, you have to hit this math button. So most of you are at your home screen. You have to hit this math button and then scroll down to option 4. Okay, now that means if I type this in, I should get the same decimal as if I type this in. I should get a matchy-matchy situation. So example 2 here, I have the cube root of negative 96. And I might not come up with a cube that goes into 96 like I did the way with 40. So I'm going to, first off, I see that it's a negative. So I'm going to split this up for the first time so you understand why this happens. I'm going to split this up into the cube root of negative 1 times the cube root of positive 96. And that's because I know my answer is going to have negative 1 times something then, because I know the answer to the cube root of negative 1 is negative 1. 96, let's say I don't think of a cube that goes into 96, so maybe I think of 12 and 8. That's the first one that comes to my mind. And then I know 8 is 2, 2, and 2 because it's 4 times 2. And I know 12 is 4 times 3. And then the 4 goes to 2 2s. The numbers, not the ones you wear. 2, 2. Now, to build my answer, I need to look for sets of 3. So I'm going to go through and I'm going to circle all of my prime numbers so I know which ones I'm looking at and I'm not getting confused by the other non-primes. And when we did simplifying square roots, we looked at every pair to make a number on the outside to build our coefficient. Now we're looking for every set of 3, triplets. So right here I have a nice set of 3 2s. That means I can take a 2 to the outside. 1, 2. And you might have noticed it up here when we did the 8, that was a perfect cube, but the suspicion a lot of times is that this other number, this 12, might break down more, so I don't know if I've done it the way I need to or if I need to keep breaking it down and see if I can find any more triplets. The good reality of this problem is that we don't have any more triplets. There's only 2 2s and a 3. So I'm going to put all of those 3 things back in. So now this time underneath the cube root, you could actually have a pair. Whereas with the square root, you weren't going to have a pair because a pair made a perfect square. So I'm going to put the 2 2s and the 3 back under the square root, or cube root, pardon me, and it's going to look like this. So my final answer here is going to be what I get if I multiply these together, so -2. And if I multiply all of these together here, I'll get 4 times 3, which is 12. There it is. So if you type this in is square root or cube root of -96 and type this in your calculator, you should get decimals that match. Okay? So take a few moments, copy down these 2 examples right here, and let's see if you can replicate or get as close as possible to the answers I'm about to reveal. Copy them down, then push pause. Or push pause now, copy them down. Here are the solutions. Don't peek. Rewind and pause if you didn't. Work it out first. See if you can come up with these answers. The example 4 there, I messed up. I got lucky and I came back to this problem before I recorded the video, and I realized I didn't have that negative in front. That is a common mistake right there, that negative number. So if you don't break it apart like I did with the 96 and the -1 over here, if you don't, you have a tendency of missing that negative value on the outside. And if it's multiple choice or even if it's short answer, you're going to lose some credit there. So, and if any of this you think is wrong, tell me, because it could be wrong. I'm just human, just like you. Okay, pause it if you're not done checking your work. I'm going to move on. So the second part of this would be with variables. So with variables and square roots, what we did is we looked for pair. For every pair that made a perfect square. Now we're going to be looking for triples again. So x to the 3rd, I'm going to write this out. So I have a cube root, if I can get my pen color changed, cube root of x cubed would really be a set of 3. So for every set of 3, I can take out 1. Okay? And if you could visualize a to the 9th, you'd have 9 a's written out, boom, 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 and you could have 3 circles of 3. So this is a to the 3rd. A shortcut for square roots was to divide the exponent by 2. The shortcut for cube roots is going to be to divide the exponent by 3. So there we go. Take a moment, copy this one down, see if you can get it. If you want to use the shortcut method, dividing the exponent by 3, that would be good. I'm gonna move it. Don't peek, pause. Did you get it? Hopefully you did. They don't get much more difficult than that, except now if you divide by 3, you got to think of the remainder, okay? Here we have cube root of x to the 4th. So I'm going to jot that one down, and I'm going to visualize this one first. And that means I can circle my triples. That means I'd have a single x on the outside and one x on the inside. For y to the 8th, and please, hopefully you don't have to do this more than once or twice before you get the idea behind it. Circle your sets of 3. There's 1. There's 2. So I'd have a y squared on the outside for 2 sets of 3. And then these would go back in. So I would have a cube root of y squared on the inside. Now to piece this all together, my coefficients are x and y squared. And my radicands are going to be x and y squared also. Okay. Example 5, I believe we can do a little bit quicker, just doing the dividing by 3 thing. If we divide by 3 to the exponents, let's just build our answer. So 7 divided by 3 is 2, so we'd have x squared with 1x left over. 13 divided by 3 is 4 with 1 left over also. So there would be our answer for this one. So see if you can come up with example 6. Pause the video, copy it down, and I will reveal the answer. Pause it. Now. Okay, let's put it all together. Variables and numerical values under the radical. Cube root of 24. Cube root of 24, I think of 8 and 3, or maybe I don't think of 8 and 3. Maybe I think of 6 and 4 first. Let's do this way. Maybe. So this would be a 3 and a 2 and a 2 and a 2. So I'm going to take my groups of 3. That's a 2 on the outside. I have 2 variables, so I'm going to leave a little room here. And I'm going to put the 3 back on the inside. Variables, I'm going to divide this by 3. So I get 1x on the outside, and that'd be a remainder of 2 on the inside. If I divide this one by 3, I would get 3 with 2 left over on the inside. There it is. Okay. Pause the video. See if you can write down the second example here and do the whole thing by yourself. Pause it. Here it is. Take a look at your work. Pause the video if you have to. That way you can double check your work. And again, if I did something wrong, let me know. Last but not least, that negative under the radical, sort of bringing this all together, full circle. Just remember, your answer is going to have a negative in it. So some people like to immediately remind themselves of that and jump down here to the answer and put a negative in front of it so they know that that's what they're going to deal with. 135, initially I would think I'm going to try to divide this by 5, and 5 goes into 135 27 times. So I can actually cheat this because I know 27 is a cube. I don't have to do the whole entire factor tree. Okay, so I know that this would be -3 with a little bit of room for my 2 variables and the cube root of 5. Okay, Divide these by 3. 16 divided by 3 is 5, so I'd have x to the 5th on the outside, and that'd be 1 left over. Divide this by 3, I'd have 6, so y to the 6th, and 1y would be left over. So this would be my answer. Again, the common mistake would be the person that forgets that negative to begin with. Okay? Copy down this example over here. Pause it. Pause it. And let's see if you can get it. I'm going to reveal the answer, so if you didn't have time to pause it now. Here it comes. All right, thanks for doing these notes, guys, because it's going to help us get more done in class where you can practice and I can be checking the work that you're doing. We're just kind of flipping this classroom situation around. Instead of doing the direct instruction in front of you, you get to do this as homework instead. So I think it's going to help us get further without getting behind, not seeing each other 5 days a week. All right, let me know how you're making out. Later.